Okay, so let's continue to our lab 4. So when you open the download simulation file, you will find this thing. And first of all, you need to set the resistor to 0.5 ohm. It is already 0.5 ohm. And the voltage source is a sine wave source with amplitude 50 volts, frequency 100 kilohertz, and the phase shift is 0. And then you can run the simulation file. Before you run the simulation file, you need to set up the logging node. It can be found from here. You can open the setting, and here you can find the things gap and set this or the settings as same as your lab notes. Sorry, my laptop stopped. Give me 1 minute to find it. All right. When you set up all this thing, you can click run, and you can and there's a result explorer open here, and you can quickly check your result from here. Here is your BH value, but this is the value versus time. So other result you can is saved in your workspace, saved all in here, the same log. So first thing you need pull out your BH value to plot a BH loop. You can because this log setting in your log setting, we ask MATLAB to save 10,000 log history. So there's a 10,000 point of B and H. You can plot a BH loop using this 10,000 point, or you can only use the first cycle. So the first cycle of B and the first cycle of H. I did this only use one loop, so let me show you. This is my BH loop. Why I do this is because I want the calculation for the power loss easier. So the power loss on this magnetic core is the area in between this BH loop. So this is the hardest part of this lab. You need to find a way to find the area inside this BH loop. I'll introduce two ways to calculate this area. So the first way is what I did here is because this is only the point, is like it's not a curve. So to integrate the area under the top line and underline is calculate the area. And to calculate the area, you can cut this area into little triangles. This is actually the basic the basic concept of integral. So I cut this as the interval of h, and cut this like this is a little triangle, and use this delta h times the b value, and do it one by one for the upper for the how to say upper BH loop, and the also the lower one, and then use this one minus this one to get the area. I can show you how I do this in MATLAB. So so I only pick the first loop. 15, not every cycle is 56 data loop. You need to open your you need to open your Simlog to see if every if your loop is 46 data, or sometimes when you do next with 200k kilohertz, it will be totally different. So choose one loop. I only choose one loop. So for my result is 56 data points, and plot the figure I showed here. So this little dot is my logged data, and using this, I calculate the delta H. So my triangle's width is here, and I calculate the area. For area 1 is the area under the upper line, and for area 2 is area of the underline, and the final area is area 1 minus area 2. So my calculation result is 226.21 for the frequency as 100K. And your lecturer suggests another way to do this. He used this way. So he pulled out the 10,000 data into Excel and use the fit function to fit the curve of the upper BH loop and lower BH loop. And yeah, and then he do the integral inside this MATLAB, inside the Excel. And what he got is 201.3 for the power loss. So you can choose either way, or you can come up with your own way. That doesn't matter, but just use your own way to calculate the area inside this BH loop and finish your lab. Okay, so that's or the introduction for the lab 4, and you can start your lab now. All right, here we got the question is how to export data from MATLAB to Excel. Actually, I don't know. And the only thing I know is when this is the same log in your you can either check the same log MATLAB file to see if you can export this raw data to Excel, or what I do is I pull out the B and H value into the using these two commands, and by this way you can get this B and H, and you can directly save from here. I guess yes, save as. Let me try. Oh. Yeah, I've already let them do. They ask how to export the data from MATLAB to Excel.
Oh, yes, the logging data.
The logging data, can this directly save to Excel?
No.
So
you
if
have
I
to,
convert this into data type and
yeah,
then
you have to
save,
extract the
right?
data from by using this command.
Yes, and
Then you export to Excel.
okay. Well, I first wait.
Because this one in the workspace is class. It's not a
Yeah,
array.
it's where do I save it? That's where. Okay. This can convert into
So what you're trying to do?
export to Excel.
You just run the command like what you did here.
Yeah, I
then you
run.
got the B and H.
Yeah, I got it.
Then B, you open the B.
Open the B. Okay.
And from here you just double click.
No. No. Save as.
Oh, let me think. B. See, that's
Save as. Save as is mat.mat. It doesn't have.
No, you export. Can you export?
There's no export.
No, you go.
But if like.
Go here. Home export or file export.
New. No. Workspace. But I know this is also a time series. By like how to say, convert the time series to double. This can work. This can.
BV.
Yeah, BV can work. BV has the export. Oh, no.
It's not save as. It should be export somewhere. It's not from home.
Yeah, I even can like this even can use a command to export this value. Let me yeah, let me find my command. Yes. Yeah, so using this command can save as Excel file. I used this.
Oh, I open. If you double click, can you open the space like
this is B.
Yeah, and where's the HB? If you
no,
that's a point name. And where's the HB? BV.
This BV is here.
Can you click BV? Yeah, I'll copy.
Oh, copy.
Yeah,
paste. All right.
You could just
all right. All right. You can copy paste the value of B and H directly to Excel. Yeah, so the loop goes like from the start point from here and it goes to here and then go back here. So either you can do look at your H value, it goes from the biggest value to the minus biggest one and then go back to the original one. So yeah, you need to open your B value or H value. For B value, you can do it first is positive and then it goes to negative and stop here. So that's how you find how many data in your first loop.